2.2.4 Docker Images and Artifacts, Concept and Reproducibility. In this part of the journey, we slow down and look at one piece of the pipeline that quietly holds everything together: the artifact, and most often, the Docker image. In the previous chapter, we followed code as it moved through the pipeline, from commit to build to testing, validation, and release. Now we slow down on one very specific element of that journey, because without it, the pipeline cannot really guarantee consistency. We're talking about Docker images, and more broadly, about artifacts. And the question behind this chapter is simple. How do we make sure that what we test is exactly the same thing that we deploy? Not almost the same, not rebuilt later, but literally the same. That's where artifacts, and especially Docker images, enter the story. Takeaway: reproducibility starts with moving artifacts, not loose code. The first surprise comes right after the build finishes, because it doesn't leave us with just code. When the build stage finishes, it does not just leave us with code. It leaves us with something more concrete, something the pipeline can store, move, reuse, and trust. That something is the artifact. In some projects, it might be a compiled binary. In others, a packaged web application. But in many modern systems, the artifact is a Docker image. And that changes everything, because suddenly the pipeline is no longer moving loose code. It is moving something repeatable. Takeaway: if something can move through environments unchanged, quality becomes measurable. To really understand why this matters, we need to look at what a Docker image actually is. A Docker image is not just a container thing. Think of it as a blueprint, a frozen snapshot of an application and the environment it needs. It contains the application itself, its libraries, its runtime, and the configuration needed for it to start correctly. The key idea is this: if the image runs on your machine, the same image will run on the CI server, and the same image will run in production. No more works on my laptop. The laptop is no longer special. Takeaway: Docker removes the uniqueness of machines on purpose. And of course, Docker images don't appear out of thin air. They are built from a recipe. Images don't appear magically. They are built from a short text file called a Docker file. It doesn't tell Docker how to do things step by step in painful detail. It declares what the final environment should look like. Each line creates a layer. Each layer becomes reusable across builds. And because the recipe is code, versioned along with everything else, the pipeline can rebuild the image again and again, and always get the same result. That's the beginning of reproducibility. And once teams taste it, habits change. They stop fixing things on servers. They fix the recipe and rebuild the image. Takeaway: fix the recipe, not the running system. Once teams start working with images this way, something deeper begins to happen. Reproducibility becomes possible. Reproducibility means the thing you tested is the thing you deploy. There's only one image. It is built once. Everything else, staging, testing, production, simply runs that same image. If it worked in staging, the team can trust it in production because they are not deploying another build. They are deploying the exact same artifact. And something powerful follows from that. If something goes wrong, you don't panic. You simply roll back to the previous image, the last one that worked. No guessing. No rebuilding from memory. Just returning the system to a known, safe state. Takeaway: reproducibility makes rollback a decision, not a rescue mission. But once an image exists, the pipeline needs somewhere reliable to keep it. When the pipeline builds an image, it does not just leave it lying around. It pushes it into a registry. That registry can be Docker Hub, GitHub Container Registry, or a private server inside the company. From that moment on, every environment, test, staging, or production pulls the exact same image from there. It's like having one warehouse that stores every version that ever existed. And the registry quietly becomes something important: the source of truth. Tagging keeps track of which version runs where. The pipeline always knows which tag was promoted and which one is currently live. Disagreements disappear. There is nothing to remember or guess. It's all there. Takeaway. The registry replaces opinions with facts. At this point, it's helpful to clear up one confusion that trips people up all the time: image versus container. We will explain it so it finally clicks. Here's a simple way to think about it. The image is the blueprint. The container is the running house. The image is read only. It doesn't do anything by itself. When Kubernetes runs your application, it creates containers from that image. You can run one container in testing, another in staging, and 100 in production. And they behave the same because they all come from the same blueprint. Many people confuse the two. But once the difference clicks, pipelines make a lot more sense. Takeaway. Images describe, containers execute. When you see all of this together, the relationship between Docker and CI/CD stops feeling accidental. So why do modern pipelines rely so heavily on Docker? Because Docker gives the pipeline something predictable to move around. The CI system builds the image. It tests it in a controlled environment. It validates that it is safe. It stores it in the registry. And then, when we're confident, it rolls out that same image to users. Before deployment, one more thing often happens quietly. And it matters more every year. The pipeline opens the image and scans it. Tools check whether any dependency or base layer contains known vulnerabilities. If something dangerous is found, the pipeline simply refuses to continue. Security becomes part of the journey, not an afterthought. Build once, use everywhere, and make sure that everywhere means safe. The pipeline stops being a fragile chain of scripts and turns into a repeatable delivery system. Takeaway. Automation is not speed for its own sake. It is controlled safety at speed. If you ever worked without containers, you probably remember the kinds of worries teams lived with. Before Docker, teams worried about different servers behave differently. Production libraries are not the same as staging. Someone changed a config manually. Why does it work here but not there? With Docker-based artifacts, something quietly disappears. Assumptions. If the image exists, and the pipeline approved it, the team knows exactly what is going to run. There are still risks, of course, but the environment is no longer one of them. And that changes people. Releases stop feeling like courage. They start feeling like engineering. Takeaway. Confidence comes from fewer unknowns, not louder promises. So Docker images solve a big part of the puzzle, but they also set the stage for what comes next. Docker images are not the whole story, but they are one of the strongest foundations of reproducible delivery. They let the pipeline say, "This is the software," and it will behave the same way, no matter where we run it. In the next chapters, we build on this foundation. We'll look at how automation tests those images, how infrastructure can also be defined as code, and how deployments happen gradually, without downtime. Because once the artifact is reproducible, the next challenge becomes, how do we release it safely every single time? And if someone ever asked you this in an interview, the heart of the answer would actually be very simple. If someone asked you in an interview, what problem do Docker images actually solve in CI/CD? A strong answer would sound calm and simple. They give the pipeline a reproducible artifact. The same image that we test is the one we deploy. That means consistent behavior across environments, easier rollback, and built-in security checks before anything reaches production. Not buzzwords, just clear reasoning. Now that we have a reliable artifact to move through environments, the next question is simple. How do we prove that it actually behaves correctly? Automatically, every time? That question opens the door to the next chapter. Test automation. End of 2.2.4.